Alright, here we go. Number 1, use the table. And this will be your x-axis, this will be your y. Okay, now your x's are the size, and your y's are going to be the number of cubes that it takes to build that picture. So size 2. So if we go size 2, it takes 1, 2, 3, 4, 5 blocks to build it. Size 3, 1, 2, 3, 4, 5, 6, 7, 8 blocks to build it. Size 4 takes 11 blocks. Size 5 takes 14. Size 6 takes 17. Size 7 takes 20. It's growing at a linear rate. Every time you go up one size, you increase 3 blocks. So you're adding 3 blocks to make the next picture every time. So that means it's linear. Let's do B first. If it is linear, it follows y equals mx plus b. Okay, now your y's are these, so the number of cubes, we're going to create a formula. The number of cubes equals the slope. M is rise over run. And these are increasing 1 every time. So the rise, this column, your y's are your up and down, that's the rise. The x column is your run. So the slope is 3. So to find the number of cubes it takes, you're going to take 3 and you're going to times it by x. So you're going to times it by the size, and then you're going to add b. And b is the beginning. B is the y-intercept. B always happens at 0. 0 is the beginning. So I'm going to go backwards a couple. If 2 is 5, 1 is going to be 2. Go back 3. 0 is going to be a minus 1. Go back 3, back 3. Minus 3, minus 3. So b, this is the b. That is where I start. I start at a minus 1. So 3 times the size plus a negative 1. That is b. Y equals 3x minus 1. Okay, now check it. 7 is an x. Plug 7 in. 7 times 3 is 21 minus 1 is 20. It works. 6 times 3 is 18 minus 1 is 17. It works. So let's do 80. What is 80 times 3? 80 times 3 is 240 minus 1. A is 239. Okay, now your domain. The domain are all of these elements in the x. The domain is the size number, but I need more specific. I need to know exactly what is the domain. What's in the domain? So your domain is, put these brackets. The domain is size 2, 3, 4, 5, dot, dot, dot. It is only these numbers, nothing in between these numbers. There's no 2.5, there's no 2.75, nothing in between 2 and 3. We're going to skip and just count whole numbers. The range is going to be kind of the same brackets. The range is going to be 5, 8, 11, 14. The range is increasing by 3. 6 is never going to be in there. 7 is never going to be in there. 9 is not going to be in there. 10. None of these numbers, and certainly no decimals. Just whole number amounts. 5, 8, 11, 14, and the dots indicate it continues to grow forever in that pattern. To identify the family of functions. Okay, 8 to 2. That went down 6, 2 to 4, that went down 6, 4 to negative 10, that went down 6. Okay, you can stop. A is linear. If it is increasing by this or decreasing by the same amount every time, that's linear. B, I need a calculator. Let's look at B. Okay, 56 to 14, that went down. So that went down. I'm going to put a negative 42. 14 to 0, that went down. Minus 42. 0 to 14, that went up 42. So I'm changing directions. It was shrinking. till it hits 0. Now it's going to turn around and grow. 14 and 56. No, 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 no. It's not 42. What am I doing here? Okay, 56 to 14 was a minus 42. 14 to 0 was a minus 14. And then 0 to 14 was a positive 14. 14 to 56 was a positive 42. So it's not linear. Let's look at the second change. Okay, from a negative 42 to a negative 14, it's getting bigger, bigger, bigger. And that went up 28 times. From a negative 14 to a positive 14, that got bigger, so it's positive 28. From 14 to 42, that got bigger, so it's positive 28. Now, this time it's plus 28, plus 28, plus 28, plus 28. That means it's quadratic. The second change is constant. That is a definition of a quadratic. Okay, exponential. Look at this guy. Exponential grows by multiplication. This you times by 3, times by 3, times by 3. If it grows by times, it's either tripling or doubling or quadrupling. If it grows by times, that's exponential. Alright, number 3. Okay, you gotta remember this. This is the unit. This number out front is the coefficient. And that tells you how many you have. This tells you what you have. If you have 3 square roots of 6, that's a square root of 6, a square root of 6, a square root of 6. You got 3 of them. The next one says you got 3 negatives of the 45s. So I got negative square root of 45, negative square root of 45, negative square root of 45. And this is just, if there's no number, it's 1. So I got 1 negative of the 54, negative square root of 54. Okay, this is what you got. You got square roots of 6, you got square roots of 45, square roots of 54. They are measuring totally different things. They are different units. So you cannot add them, because they are not like units. You can only add like terms, like units. So the trick is, in 45, that's a big number. There's a square. Let's take it out. So 45 is the same as 9 times 5. 5 is done. 9 is the square. 9 is 3 squared. So here's what you got. You got a negative 3 times the square root of 3 squared times 5. Okay, now this square root is going to undo this square. So the 3 comes out, because the square root of 9 is 3. And on the outside there's already a negative 3. So you take what is already there, what you bring out, you times, and 5 stays in. So negative 3 times 3 is negative 9 times the square root of 5. This one is done. So I'm going to plus 3 square roots of 6. Now let's break up 54. 54 is a big number. 54 has a square. It is also 9. 9 times 6. 9 is 3 and 3. 6 is done. Nothing is in 6, just a 3 and a 2. So you're going to take this 3 outside, and there's a negative, so it's going to be a negative 3, and on the inside is just your 3 and 2, just your 6. Okay, now look. These will now play with these because they're both measuring by square roots of 6. These are like terms. So if I got 3 negatives of the square root of 6 and I got 3 positives of the square root of 6, that's a negative square root of 6, a negative square root of 6, a negative square root of 6, a positive square root of 6, a positive square root of 6, a positive. A negative and a positive is 0. 0, 0, 0. So they're going to zero each other out. You just add the numbers in front. You add the coefficients. So that and that will zero out, and you are left with negative 9 square roots of 5. Number 4. Okay, number 4 is just all times. 3 times x squared times this, under the square root, 12 times x, 5 times y is 6. Okay, let's bust up to 12. There's a square in 12. In 12 is 4 and 3, and 4 is the square, because that's 2 and 2. I know the square root of 4 is 2. because that is the square root of 2 squared times 3. And that square root is going to kill that square, so 2 is on the outside. Okay, on the outside I got a negative 3. So I'm going to have a negative 3 times 2. On the inside, I've got 3. Okay, on the outside I got x squared. Now look right here. If I've got x to the 5, I got 5 of them. That is going to be a square, and 1 left over. 2, 4, 5. 5 x's. In 5, there are 2 squares. So the square root's going to kill this square, and it's going to kill that square. So this x comes out, this x comes out. So I've got times x times x. This x stays in. Okay, the y. If I've got y to the 6th, that is 3 squares. Y square, y square, y square. 2, 4, 6. So you're going to have 3 y's come out. So on the outside, a negative 3 times 2 is a negative 6. X squared times x1 is x to the 2 plus 1 plus 1. Outside you've got 4 x's. And you're bringing 3 y's. And then on the inside, the 3 stays in. And you had 1 left over x that stays in. And that is it. Okay, number 5 is a multiplication. This is 3, 1. Let's see, you got 3 squared, it's 10. And that's times 3 times the square root of 10 times 3 times the square root of 8. Multiplication, you times the coefficients. Take this and times them. 3 times 3 is 9. And you take these and you times them. The 10 times 8. But they need to stay underneath. So look at this, 10 times 8. Instead of timesing them, I'm going to break them up. Inside 10 is a 2 and a 5. Okay, inside of 8 is a 4 and a 2. And 4 is 2 and 2. So, now check it out. I have a perfect square there, and I have a square here. This 2 and this 2. So on the outside I got 9. On the inside, I've got 2 squared, and again, I've got 2 squared. And then I've got 5. Okay, so this square root is going to kill this square, so 2 comes out. This square root kills that square, 2 comes out. So on the outside you got 9 times 2 times 2. And on the inside you've got 5. And 9 times 2 times 2 is 36 square roots of 5. That's a lot of square roots of 5. You got 36 of them. Number 6. Okay, you cannot ever leave a radical on the bottom. Bad news. But the ends are cool, because if you've got the square root of 3n to the 4, that's the same as square root of 3n squared and squared. These ends are going to come out. The square root is going to undo the squares, and you have 2 squares. So kills that, n comes out, n comes out. So on top you have 2. On bottom, you've got 5n squared square root 3. Okay, now you cannot leave a radical on the bottom. So you're going to times this by some clever 1. You can times anything by 1 and not change its value. The 1, I'm going to change this square root of 3 into a perfect square. I'm going to change it to a square root of 9. So times the bottom by square root of 3 times the top by square root of 3. Now the top, 2 is on the outside, and so it's got to times what's on the outside, which is a 1. So on top you got 2 square roots of 3. On bottom, square root of 3 times square root of 3, you did it. You got 5 n squared square root of 9. And square root of 9 is 3, so you got 5 n squared times 3, and the 3 and the 5 times together. So on the top you still have 2 square roots of 3, and on the bottom you've got 15 n squared. Okay, number 7. Okay, 7 is a multiplication problem. Okay, now parentheses, if you do the parentheses first, you have two 1s. So you got a 1 and you got a 1. And then you got 3 negatives of the square root of 3. Negative square root of 3, negative square root of 3, negative square root of 3. Okay, this mess does not add because 1s and square roots of 3 are different units. So you cannot add what's in the parentheses. So let's times. Now when you times is pretty easy. You times the 3 to the 2. And 3 times 2 is 6. And you times the square roots together. This is square root of 6 and this does not have one, so it's just square root of 6. So now let's times to this guy. You times the coefficients together. 3 times a minus 3 is a minus 9. And times the radicals together. Square root 6 times square root 3 times the 6 and 3, and you should get square root 18. And 18 is a big number. There's a square in there. It is 9. 9 times 2, 9 is 3 times 3. So 18 is really 3 squared times 2. And that square root is going to undo the square. So 3 will come out. And on the outside you got a negative 9. So you need to do negative 9 times 3. On the inside you just leave the 2. So on the outside we've got a negative 27 square roots of 2. And then with your 6 square roots of 6 and square roots of 6 and square roots of 2 are not like units. They're measuring totally different things. So that is your answer. Cannot combine square roots of 6 with square roots of 2. Okay, 8. Let's look at the outsides. 4 and 2. That will clean up to be 2 and 1. Now clean up your insides. 5 and 15 play together. That's going to change to a 1 and a 3. And then look at this. Your x's will even play together. 3 of these x's on top are going to undo 3 of the x's on bottom. So 3 of these x's on top kill 3 of the x's on bottom. So I just have 1x. Okay, now on top, square root of 1 is just 1. So here's what you got. You've got 2 over square root of 3x. And you cannot have a radical in the bottom. So I'm going to times this by 1. Your 1 is whatever this is. So square root 3x, square root 3x on top and bottom. On top, 2 times square root of 3x is going to be 2 square roots of 3x. On bottom, square root of 3x times square root of 3x is going to be 9x squared. So you just created a perfect square. Square root of 9x squared is going to simplify to 3x. And 2 and 3 have nothing in common, so you can't simplify that. And this x is on the outside, and this x is on the inside, so they cannot play together. So you're done. That is your answer. 9 and 10. Okay, now, these ones, no square roots, you're just playing with exponents. Let's do the top. So let's do, it's all times. Times, 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 times. Times the 2 and 4. That's 8. And now let's do your x's. X squared and x1. So that's addition, add them up. So that's x3. And your y's are going to be y7. And bottom is already cleaned up as far as it's going to go. So you got 3x minus 3y2. Okay, now there's a rule. You can never have a negative exponent. So find the negative, and if it's on the bottom, move it to the top where it will become positive. So here we go. On top we've got 8x cubed y7, and you're going to bring x3. When you move it to the top, it becomes positive. On bottom, now that's gone, you just have 3y squared. Okay, now 8 and 3 have nothing in common, so that is your final answer. 8 and 3. Your x's, x cubed and x cubed is going to be x3 plus 3, so that's x to the 6. And then your y's, Now look, y's on top and y's on bottom. 2 of these y's on bottom are going to divide out 2 of the y's on top. So you have 5 left over on top. So on top you should have y5. That is where you end up. You cannot simplify any further. 10. Anytime you have exponent 0, that's just a 1. So it's really 1 times y squared, which is just y squared. Okay, now, the parentheses, you need to take this 2 to everything. The 2 has an exponent, it's 1. Take it to the 2, take it to the x, take it to the y. And if they already have exponents, now is where you times them. So here we go. You've got y squared times 2 squared times x to the 6. 2 times 3 is 6 times y. Negative 1 times 2 is negative 2. Okay, now look, these y's, combine them, you add them, so it's y2 plus negative 2, which is y0, which is 1. So your y's cancel out. 2 squared is 4. Your answer, 4x to the 6th. Last page, except for the bonus. Okay, irrational. Irrational are these: square root of 3, square root of 5, square root of 6, square root of these. If you turn these into decimals, they are decimals that go on forever, and there's no pattern. These are the rational. This is irrational. This is rational. Rational is like 0, 1, negative 2, 3, negative 6, square root of 4, square root 9. So A, B, C, D. Which one is crappy? Which one sucks? So you could just type these in your calculator, A, B, C, D, type them in, and see which one sucks. And it is, let's see, A. 2 times negative 4 is negative 8. Times the underneath. 2 times 18 is 36. Okay, that's awesome. Negative 8 times 6, negative 48. That's okay, that's good, it's not A. Square root of 36 is perfect. B, 20, okay, these play together, 27 and 3, divide them. 27 divided by 3, that's the same as square root 9, which is whole number. That's cool. C is cool, because the square is going to kill the square root, so it's just going to be 3. So it is D. Now this one wants to know which number is legit, which number is a good number, like these, like A, B, and C. Alright, square root of 3 cubed is square root 3 times square root 3 times square root 3, which is square root 27. That is a crappy decimal. That number sucks. So it's not A. It is B. Because 27 divided by 3 is square root 9, and that is 3. This is square root 8. That sucks. That's a decimal. This, you cannot add them. This, though, is 3, so it's really square root of 2 plus 3 ones. So B is the one that turns into a sweet number. And the bonus. Okay. This is a big old number. Let's divide it out. Okay, I'm going to divide it by 1,000. So if I go 108,000 divided by 1,000, take off 3 zeros, and that is 108. Okay, 1,000 is 100 times 10. And 100 is 10 times 10. That is my square. 10 I can break down to like 5 and 2. Done. 108, I'm going to divide that by 4. 4 and 27. 4, that's a square right there, because that's 2 and 2. 27, 9 and 3. 9's a square, because that's 3 and 3. So here's my squares. I'm going to take a 10 out. I'm going to take a 3 out. I'm going to take a 2 out. So with my negative 4 times 10 times, what else did I take out? 2 times 3 Now what stays in is, let's see, this 5 right here stays in, that 2 stays in, and this 3 stays in. So 5 times 2 is 10 times 3. So I got 30 that stayed in. Okay, now on the outside, negative 4 times 10 times 2 times 3. On the outside, you should have negative 480. Okay, these x's. Oosh, if you've got 47 of them, here is how many squares you got. How many squares are in 47? There's going to be one left over. Okay, now, if I do 46, that is going to be 23. So 23 squares is 46, and there's my 47th. So that means if I've got 23 squares, I am taking out 23 of these x's. So I'm taking out 23 x's, but there's already 3 x's. So on the outside, I've got 26 x's. And your y is 131 is going to be this. I'm going to do this 130 times y to the 1. Okay, now this, in 130, if I do 130, how many 2's are in 130? How many squares divided by 2? This is the same thing as 65 squares. So I am bringing out 65 squares. And there's already one out here. So there should be 66 squares. So my 30 stays in. My leftover x and my leftover y stay in. And that is it.